Okay, in the last lecture we discussed about the continuous casting, and we have discussed basically various units and their functions and also continuous casting defects. Now in this lecture we will talk about some downstream processing of the continuous casting as well as near net shape casting. So these are basically the downstream processing like reheating and then hot rolling, cold rolling, galvanizing. These are the upstream processing, and then I will talk about the near net shape casting, and it's very brief. So reheating is what? That is the ingot, bloom and billet slabs are basically required to be reheated before hot rolling and to convert them to more sellable product like your plate, sheets and wares. So they have to be hot rolled because their thickness is much higher. So now they have to be reduced significantly, okay, to a sheet thickness, that is the 1 to 5 millimeter sheet thickness like that. So you can see it is so 150 millimeter like that, all these things are there. So thing is that, and then what is that they have to be reheated above the decrystallization temperature when the slip system become much more. I am just telling, that is the reheating is done to a temperature above the decrystallization temperature where the slip system become much more active to facilitate the plastic deformation with ease. Okay, and also above decrystallization temperature all the strains get released because you are doing the annealing also. Decrystallization means fresh grains are formed, so your previous strain are relieved, and then the slip systems are also active, so you can easily deform it. Okay, that is the hot rolling, so you can, energy requirement is much less. And reheating furnace is either fuel fired and electrically heated. One thing I will take that is talk about this, because reheating, as I said, it is essential, because when you make the continuous casting also, when the casting is coming out, because after secondary cooling your surface get cooled also, and then finally the surface temperature may be 600-700 degrees centigrade, that is then that has to be, again it has to go through some reheating furnace. So reheating furnace can be either fuel fired and the electrically fired, it will be on the line only, in line, so everything in line. So after the casting is continuous casting, after it is shared, that is that the block goes into the your reheating furnace in the line, and then from reheating furnace directly enter into the hot strip mill. Three types of reheating furnace exist. One is called the batch type. As you can understand, it can go and stay for some time, and this is batch type is used mainly for the your ingot casting. That is the ingot casting, the reheating furnace, or for ingots the reheating furnace are usually batch type. You put the ingot into the machine, keep it for some time, when reheat it, and then take it out, and then you can do it. And this is the continuous pusher type continuous furnace with moving refractory heart. This is used, and in this case what happens, a rotating hearth is there, and rotating, what you say, that there is the base or the hearth also you can say, where the object is laying on the hearth, and the rotating hearth carries the object from one end to the other end, and during this process the reheating takes place. Another is called the walking beam furnace, where the charge moves intermittently through different zones. It first moves in a first zone, and then furnace is there, and then the temperature is in the preheating range, and then it moves into a higher temperature regions for heating, and then it moves into another zone where basically the soaking takes place for some time, and then it comes out. That is called the walking beam furnace. Okay, so all this type I am just taking from different papers. That is the batch type reheating furnaces. You can see there is the solid charge is there, you have a burner, fuel burners are there, so it gets heated up, it is kept for some time and then taking out, and then it directly goes for the forging or rolling purpose. And this is the pusher type. You can find there is the billet comes in here, and then it moves in this direction, okay, and there are the burners, and the gas moves in the counter current direction, and so initially this basically get preheating, and then it is heating, and the very final heating stage is here. This temperature is increasing, and finally it is coming out of the furnace. So progressively the billet is heated from room temperature to from the lower temperature to a very high temperature, whatever is required, and then they go. So from the continuous casting they can directly come to the pusher type, at 700-800 degrees surface temperature, and then they can be heated up to a very high temperature above 1000 degrees centigrade for further rolling operation. And this is, you can see, this is called the working beam furnace. Here basically you can see the solid material comes in the zone 1, they stays for some time, and then again they are pushed to the next zone, they stay for some time and then get heated. So temperature basically increases progressively as you move in this direction. And then zone 3, that is the heating 2, here basically you have little higher temperature and then the material is soaked in this temperature, and then finally it moves to the 4th zone, and then there also they get it to a much higher temperature and finally they come out. So this is called the working beam furnace. Now hot rolling. So this is the hot rolling, basically deformation under compressive load under hot condition. So hot condition, if you do the deformation, that is called the hot rolling. So you can, in the hot, there is the hot strip mill, you can produce plates like of 10 millimeter thickness directly from the ingot and the slabs. Slabs may have a thickness of 150 millimeter to 10 millimeter plates, you can make it. Reduction in thickness is done in the roughing and the finishing mill, where the ingot and slab are allowed to pass through water cooled rolls intermittently. So here basically reheating furnace, and it is slab is coming, and this is the roughing mill. Roughing mill means it decreases the thickness, and then finally the desired thickness is obtained very say 10 millimeter. Say here it is roughing mill up to 50 millimeter, and then 10 millimeter comes into the what is that called? That is the finishing mills. So finishing mills, you get the finally the desired thickness, and these are all water cooled basically rolls are there, and then it is cooled, and then this is the coiler through which you can coil the sheet. And it is very well known that during rolling oxidation take place at the surface. Obviously it is exposed to the atmosphere, oxidation will take place, so scale formation take place, but those scales are not very adherent. You can take it out by high speed water jet, and this scale is called the mill scale, as you know. So you can take out during the hot rolling. And in modern plate mills are equipped with customized thermomechanical treatment. You can do the accelerated cooling and heating and tempering, all facilities are there. So heat treatment you can do subsequently as required. What type of microstructure development you want, depending on that, there is the thermomechanical treatment is available. So final structure become very strong and malleable. Now sometimes the cold rolling, because about 50% of the product are sold in the hot roll condition only, sheet, plates and all this, and some special products are there which requires the cold rolling. And advantage of the cold rolling is that cold rolling can give a particular texture to the product, and these textures are helpful for developing some special property of the steel. That's why cold rolling is needed. So that's why I am telling this. However, numerous products require cold rolling for further reduction in thickness with good surface finish. Surface finish, usually cold rolling is much better. That is another advantage. Cold rolling done under the recrystallization temperature. Obviously, it doesn't go beyond the recrystallization temperature. So it basically, when you do the cold rolling, your strain structure you cold roll. So as a result, work hardening takes place. So the structure becomes higher in hardness. It becomes much more harder. Yield strength is higher, but at the expense of the formability. Its formability decreases to some extent. But cold rolling can impart a favorable texture to the product. Favorable texture means favorable grain orientation that can produce some special mechanical property. That is obvious. That is, before the cold rolling, the hot roll strips are descaled by hot blasting and the acid treatment like pickling to impart the better surface finish, because before it goes into the cold rolling you have a very good surface finish. No scale should be there. Okay, that is there. Cold rolling can be accomplished in a single reversing mill equipped with an uncoiler and the coiler. A single strand you can do. It can do one pass and then again another pass, one pass, another, like that. Or it can be continuous tandem mill where the strip is engaged in several strands, just like hot strip mill. So one after the other it can go. Cold roll products are annealed. It has to be annealed because lot of stains are generated that has to be released. So annealed under specific situation to regain some of its ductility also. If your stain is released, you can get some more ductility. So some products are there which require some annealing after the cold rolling. Now I coming to the near net shape casting. As I said, this is a tremendous breakthrough of continuous casting. We can now cast a thin slab casting which is a thickness of 50 to 80 millimeter. So it obviously decreases the roll. You may not, you can see that is, this is the ingot casting. You can see that I have just compared. There is a thin slab casting, the 50 to 80 millimeter, and the strip casting, it can have 5 millimeter. Okay, now you can see is the process integration. You can see in case of the ingot casting, you have to give the ingot to the reheating furnace, and there is from room temperature to that, and then it will go to the slabbing mill. Then it will make the slab, but continuous casting directly produce the slab. Okay, so in case of the ingot, you have to reheat furnace and then slabbing mill, from slabbing mill to reheating furnace. Okay, then it enters into the roughing mill. In case of the continuous casting, it can directly come into the roughing mill, or after some preheating. After some preheating, it can directly come, or depending on temperature, it can come through the reheating furnace and then goes to the roughing mill. From roughing mill, then it goes to the finishing stand and the pickling, heat treatment, and the cold rolling, and then to the customer. In case of the thin slab casting, that is the 50 to 80 millimeter thickness slab casting, in that case, it can directly enter into the finishing stand. Okay, and then pickling treatment will be there, and then cold rolling and to the customer. And in case of the strip casting, it can directly enter into the cold roll mill. Okay, or it can directly go to the customer depending on the surface finish and all this thing. So you can see by this way we can do the process integration, we can save the lot of energy. Okay, we are moving near net shape casting. That is here it is almost the same. You are directly casting the sheet. So that can goes to the customer, provide the surface finish is very good. So that's why that is the strip casting is not commercially, that is it is commercially produced, but that is the scale of production is not that much. It is not, we are not getting, people are not getting the required surface finish directly if you go to the customer, or sometimes the strip casting it goes through the cold rolling mill to improve the surface finish. Okay. So near net shape casting, that is the seam slab casting. It is basically cast in a special mold. It is called the funnel shaped mold. It's unlike in a rectangular mold, it is a funnel shaped mold, and then it has started producing commercially in 1990, thin slab casting, and 14 million ton was produced in 1990, and today more than 100 million ton. And in India we have SR and JSW in India has the thin slab casting, SR in Hazira, Gujarat, and presently it is the ArcelorMittal group, they have taken up the SR steel. And JSW Ispat in Raigarh, Maharashtra also has this thin slab casting mill. Various grades of, now initially it was only limited to low carbon steel, now today various grade, low carbon, medium carbon, and then even the IF steel, that is the automotive steel, interstitial free steel can be cast by the thin slab casting. So, and various technologies are there. Compact strip production by SMS Germany, that was the original thin slab casting. They are the original producer. They are the first producer of the thin slab casting. Inline, that is the inline strip casting ISP of MDA, that is also German. That is the management DMAG companies. That is they are also producing inline strip production. This is also a parallelly developed thin slab casting process. And flexible thin slab casting, that is by Daniel Italy, that is also another technology of producing the thin slab casting today. And so and strip casting, in case of the strip casting you don't require any molds, no mold is required. It is basically you have two water cooled drums is there through which the liquid steel is poured and then it cast. Okay, twin roll caster it is called. Improve mechanical properties, small equiax grains. Obviously here the casting rate is very fast, so you have get more equiax grain, less segregation, finer inclusions. Commercial plant is there in Nucor cast strip, Indiana, USA. Another is there in the Hikari, Japan. So this cast strip has not come in a very large scale commercial production, although the strip casting already is a very large scale commercial production. Even in India we have 2 thin slab casting machine and it is developing, but strip casting is to develop some time, because if you want to directly get to the near net shape casting, the surface finish is very important, and then so you have to grow in a large scale production. Okay, but these are the breakthrough, and if you can do that, you can do a lot of process integration, energy savings, lesser CO2 emission and everything. So these are the some of the Deepak Majumdar first question, iron and steel making is sufficient. These are basically I have taken for different reheating furnace from literature. Okay. So downstream processing of casting involves hot rolling, heat treatment, pickling, cold rolling, annealing process followed by coiling, and all these downstream process convert blooms, then billet, slab to sellable products like sheets, plates with enhanced mechanical properties through customized, that is very important, thermomechanical processing today. We can do that. Cold rolling can introduce some favorable grain structure, as I said. And near net shape casting like slab casting 50 mm and strip casting 2 mm thick are recent breakthrough of continuous casting. Thin slab casting, that is the may not require any roughing mill, and it can directly enter the finishing strat and developed significantly, and the strip casting does not require any hot roll milling and can directly enter the cold roll mill, yet developed to a large scale production. Okay, but they are definitely a very great breakthrough. Thank you very much.